Lesson 4.5, fractions and decimals. So today our job is to take a fraction and be able to convert it to a decimal, or take a decimal and convert it to a fraction. So some of these are a lot easier than others. Pretty much going from a fraction to a decimal, you have to divide the numerator by the denominator, because when you see a fraction like 5/9, the bar that is in between them means, yeah, it sure does, it means divide. So you're going to divide the numerator by the denominator. So let's look at the very first example. It says write 5/9 as a decimal. Well, when you take 5 divided by 9, as they have right here, every time you look at that, 9 doesn't go into 5 directly, so they have to add a decimal, and then they keep adding zeros. And every time they do that, that is 9 going into 50, which is 5 times, and 5 times 9 is 45. And then every time they subtract, they get 5 left, and they keep adding the 0 and bringing it down. And then 9 goes into 50 again, 5 times 45. Well, it keeps giving the value of 5. It's never going to stop. So that is called a repeating decimal. That is called a repeating decimal, and the way that you show the repeating decimal is that you use a repeating bar. So it is a repeating decimal, and how you write that, it is 0.5, and you put the bar over it. That's bar notation. So bar notation, you're showing 0.5 with a bar, and it means the 5 repeats forever. 0.5 repeating. Sometimes you might have 2 digits that repeat, and then you would put the bar over the 2 digits. And sometimes it's 3 digits that repeat, so you'd put the bar over the 3. It just depends. So some of them are just going to be a terminating decimal when you divide it out, and then it just stops. If it is repeating, then you'll put the repeating bar. Second, we're going to take decimals and write them as fractions in simplest form. So when I see 0.32, I usually say 0.32, but if I read that correctly without saying point, what is that number?
32.
32 what? What place value does that represent? 32 what? What is it? Hundredths? 32 hundredths. And then whatever that would be, it's 2 places. So 32 hundredths would be the decimal equivalent, or the fractional equivalent to 0.32. And then reduce like we did for today, which would be dividing both by 4. They got 8/25. All right, let's look at some examples of this and see how it works out. So we're going to look at the odd ones. Number 1 says 8/10. It says write each fraction or mixed number as a decimal. Use bar notation if the decimal is a repeating decimal. So 8/10 is probably a good one to start with. You take 8, that's the numerator on the inside, divided by 10. 10 doesn't go into 8.
It goes into 80.
Add a decimal here,
0.
and add a decimal up above the division bar. I add a 0. How many times does 10 go into 80? 8. And 8 times 10 is 80, so that when I subtract, there's no remainder. That means it is a terminating decimal. And that 8/10 is 0.8, which, how do you read 0.8 without saying point?
8/10.
8/10. So therefore, it's the same thing. Okay, let's look at number 3. 7/11. It's not like the convenience store, 7-Eleven. Question, Freddie?
You're only giving us 4 questions?
We're going to do these examples. I'm not sure how many we're going to have in the assignment. Yeah, we're going to do the odd ones. 7/11. So we take 7 inside and 11 on the out. I'm going to put a decimal and bring it straight up. And we know, just like the others, 11 isn't going into 7, so I add a 0. So how many times will 11 go into 70, Trevor?
7.
Does it go in 7? What's 7 times 11?
6.
What's 7 times 11, Trevor? What's 7 times 11?
77.
Will 77 go into 70?
No.
No. So we better not do 7. So maybe we should try what, Trevor?
10.
Where 11 goes into 70. How many times?
12.
How many?
6.
6. And what is 6 times 11?
66.
So 66, and I'm going to subtract. And 70 minus 66, how many is that?
5.
Not 5.
4.
4. So there's still a remainder, so we've got to add another 0 and bring it down. How many times will 11 go into 40? 3. So that's 33, and what's left over? 40 minus 33.
8.
What does it skip?
7.
7. And when I bring down that 0, look what we've got. 11 into 70. 6,
Can't do this.
which is 66 again, and 4 left over, and now what? Another
Can't do it.
0. What's going to happen?
Not gonna be able to do it.
It's going to go on forever. So what digits are actually repeating? Skip? 63. So you put 0.63 with the repeating bar over the 6 and the 3. Now I am going to tell you this from up here. I went ahead and added a 3 here just so you could see it. But let's say most of you knew right there at 636 that it was going to be repeating, didn't you?
Yep.
And please don't do this. Please don't divide it and then just say my answer's right here and put a bar like that. Because who can tell me the difference between that and the actual answer of 0.63? What's the difference between just 0.63,
It's 600.
63 repeating and 0.636 repeating? Trevor, what's the difference?
It's 100.
It's 100, but if we wrote that top one out there, what's it going to look like? Point what?
636.
636, 636, and so on, right?
Yeah.
Yep.
But this one, what's it going to look like?
63.
Like that. 63, 63, 63, 63. Well, what's the difference? What about the one at the top? What's the difference?
2 6s.
There's 2 6s in a row, so that's a mistake. That's not really
Yeah.
what we mean. So be careful when you write the division or the repeating bar. Make sure it goes over just the actual numbers that repeat. Okay, number 5, 13 15ths. So let's go 13 divided by 15. 15 doesn't go into 13. I'm going to add a decimal and take it straight up and add a 0. Okay, this might be a little trickier. How many times will 15 go into 130? Might be a little trickier, huh?
6 times.
6 times? What is 6 times 15? What's 6 times 5?
36.
6 times 5 isn't 36.
It's 60.
It's not 60. 6
30.
times 30. 30. And 6 times 1
96.
plus 3. It's 90.
Or, yeah, 90.
Is 90 big enough?
Yeah.
If I subtracted 90 from 130,
No.
not big
Keep
enough.
going.
So what should I make it?
Keep going.
Higher than 6. What should we try this time?
9.
8.
9.
8. Let's try 15 times 8. So what's 8 times 5?
45.
40, not 45, 40. 8 times 1 plus 4. 12.
Oh, I mean,
So 120, is that big enough?
getting there.
Yeah.
Yes. So we're going to go 8. That's 120. And now there's 10 left. We got to keep going. So how many times would 15 go into 100? I think we know that, don't we?
Yes.
What was the one that we tried?
8.
8 was 120, but
6.
before that, 6 was how much? 90. So
90.
6 is 90, and there's 10 left. Uh-oh. Now what?
It's going to keep repeating.
It's going to keep repeating, so we're going to keep doing 6 again, right?
Times 9.
And it's 10 left. It's just going to keep going.
Yeah.
So what is actually repeating on this one? What is
86.
just the 6? So it's 0.86, and the repeating bar is over the 6 only. It's over the 6 only. Okay, questions about that? Now we're going to write the decimals as fractions in simplest form. Here's number 7 is 0.14. Somebody please read that without saying the word point. What is that correct number?
1400.
Michael?
14,
14 what?
100. I mean, tens.
14 tenths.
How many decimal places are there, Michael? How many decimal places?
2.
2, so there should be 2 zeros.
100.
And 1,000.
2 zeros.
100.
100.
Hundredths. 14 hundredths. Now let's reduce that. What's something we know for sure we can divide out of 14 and 100? Irene? Definitely 2. So let's divide them both by 2. What's 14 divided by 2? 7. What's 100 divided by 2?
200.
No, divided by, not multiplied. 7 over 50. Does anything come out of 7 and 50? Is 7 prime? 7's prime, so the only option is if 7 would go into 50 evenly, does it? Nope, so it's 7/50ths. Okay, last but not least, 0.94. Somebody give me that one as a
9400.
94 hundredths. What do we know for sure that'll come out of 94 hundredths, Irene?
2.
Does
No.
2.
2 again. Let's try 2 again. Okay. Anybody know what 94 divided by 2 is? Do you know? 94. We better do it this way then. 94 divided by 2. 2 goes into 9 how many times?
4.
4. 2 times 4 is 8. So when I subtract, there's 1. I'm going to bring down the 4. What about 2 into 14?
7.
7. So 47, she says. Yes. 47 on top. What about 100 divided by 2? 50. Can we reduce 47 over 50? Nope. Nothing in common. So that is your final answer. Changing fractions to decimals and decimals to fractions.